we have made it to the second official step, but in my opinion, the third, known as the Kreb cycle. This is where the complete oxidation of glucose is going to occur. And we do this through the molecule known as acetyl-CoA. And so we're going to disassemble this molecule. And as a product of that, we're going to release the waste product known as carbon dioxide. We're going to generate a couple energy molecules known as ATP. But for me, the most important part of this is we're going to generate electron transport molecules or electron carriers known as NADH and FADH2. So again, the next slide that I'm going to show you is not in your PowerPoint. And I didn't put it there because I don't want you to go back and study all the different parts or get overwhelmed. But for those of you who like to understand where these molecules and these numbers are coming from, let's take a look. Whoa. This is the Kreb cycle. And I know right now you're like, why? But we're going to check it out. And that just freaked my dog out. Anyway, so basically we're starting right here where it says number 1. And we're taking that acetyl-CoA. And just to let you know, they're showing you it's C2, right? And you can see there's 2 carbons here. That's why they're saying it's a C2. And we basically made that from the pyruvate to shuffle it into this cycle. Why do we call it a cycle? Well, do you notice that we start here? We combine the acetyl-CoA with this molecule called oxonal acetate. This is a C4. You can see 1, 2, 3, 4. And these 2 things come together to make citrate, which is a C6. And you can see all those carbons there. But as you go through this, it's a cycle because where you start is where you end and where you end is where you start. So that's why they call it the Kreb cycle, because it's just this process that continues to go around. As you can see, there are different steps. You have this 1, 2, 3, 4, 5, 6, 7, 8 steps here. And if you look at each one of those steps, you'll see at the end of those words here, you'll notice the 3 little letter sequence that tells us these are all enzymes. That's known as ACE. And they tell you essentially what they're doing. For instance, look at the very first step. It makes citrate. So it's called citrate synthase because that's what it's doing, which is the reason why I love enzymes and proteins. Anyway, what we're doing in this process essentially is we're oxidizing that acetyl-CoA, which if we remember, if we take the original trip all the way back to glycolysis, was originally glucose. Now, they don't show you this here, but from that one glucose molecule, there are 2 of these acetyl-CoAs. So both of those are going to feed into this. So this process happens twice. So let's analyze one go around of this. As we go through here, you'll notice we combine these 2. So we have a C6, changing it around a little bit, right? If you really want to know, look here. Now we have an OH where before we didn't. And that's going to allow us to get this molecule ready to use this enzyme to take NAD plus and convert it to NADH. So essentially what's happening here is we are taking and reducing that NAD plus to make NADH. So we're taking some of the electrons here. And how do we know? Well, this was OH and now it's double bond to O. So you've seen that change. It comes over here. This one right there, it's going to essentially go away to that last part where we go and we talk to the electron transport chain. Not only that, though, do you see in that process it also makes carbon dioxide? Because if you look, do you see how we have, I think of that as COO, C-O-O-O? Well, that's gone here now. So essentially, it clipped this off in the process as well. And so we have carbon dioxide being released as a waste product here. Once we make this molecule, something very similar happens. You have the coenzyme A that comes in there, that attaches here and allows this whole Q to go off, right? Which we make another carbon dioxide. In that process, though, we steal the electrons from that area. And then again, we have NAD plus that goes to NADH. We're going to keep moving on. And you see we're going to go through here. And then we're going to get to this area that's right here. Now here, we have made 2 electron carriers known as NADH, right? But on here, this is a little bit different. We have FAD that goes to FADH2. This, though, think it's just a lot of letters like this. This is an electron carrier as well. So we have one of these coming in to make one of these. Now the last electron carrier that we're going to make is here. When we have this malate, which is C4, it goes to C4, it changes it around a little bit. If you look here though, you go from OH to O here, you're not losing any carbons. So on this one, you take NADH and you reduce it to NAD plus, reduce it to NADH, and you're not losing any carbon. So you're just making an electron carrier there. Now, so this happens, so we make, looking at electron carriers, we make 3 NADHs per cycle. So since we have 2 acetyl-CoAs, you're going to make 6 of those. You make 1 FADH2 per cycle because you have 2 acetyl-CoAs, you make 2 of these. Now, the only thing I haven't pointed out is you actually make 2 ATP molecules here too. And that's because this process of making GTP, which sounds a lot like ATP, right? Because it's very similar. You actually generate 2 molecules of ATP, one at a time, right? So every molecule of this GTP that you're essentially making, it is allowing this GTP to essentially make an ATP molecule, okay? So because this happens twice, then essentially you make 2 ATPs. So let's go back and look at the outputs of these, right? And remember, this just keeps cycling. It never ends. So we start with 2 molecules of acetyl-CoA. That's right here. We're doing 2 molecules of ADP because remember, we made 2 here. 1 for each cycle that we go around. 6 NAD pluses. If you remember, we have 1, 2, 3, and this happens twice. 2 FADs, and it's 2 because you have it right here, and this happens twice. And then what we make are 4 carbon dioxides. Why? Because when we look at this, you only make 2 carbon dioxides. This third one doesn't have one. And this happens twice, so you make 4. You make 2 ATPs. Remember, down here, you start with GTP. So it goes from ADP to ATP, thus the 2 ADPs and the 2 ATPs, because this happens twice. 6 NADHs and 2 FADH2s. So you have 1, 2, 3 NADHs. This happens twice, so it's 6. And 1 FADH2, it happens twice, so it's 2. And so what we're going to use at this point, we don't have any more of the original carbons from the glucose molecule that we had, right? Because whatever's left over will continue to cycle in the Kreb cycle. What we do have, though, now is these electron carriers, NADH and FADH2. And that's going to continue to the next cycle or step. I said cycle, I apologize, to the next step.